Hello everyone, welcome to my talk, The DNA of Highly Effective Teams. My name is Achim Wiedemann and it's a pleasure to be here at GeeCON. First time for me, so I'm pretty excited about it. Before we get started, a little bit of context about myself. I'm a software engineer, have roughly worked 18 years in the field, worked in 5 companies across 2 continents, and I've worked with 7 teams so far. Currently I work for Bosch Digital and Bosch e-bike systems on a cloud backend for the e-bikes. This is a talk about team culture. The technical side of software development is fascinating and there's a lot of material on it. We've got a lot of books, we've got a lot of great material on the internet and so on. But the cultural side is less covered, but I think equally important. So what is culture? Well, Terence Steele and Alan Kennedy defined culture or organizational culture as the way things get done around here. And I think that's a pretty intuitive and also pretty general description that we can ascribe to culture in general. So over the years that I have worked with my teams, I observed several behaviors, practices, and constellations. And in the teams that I worked with, and some of those made the teams more efficient than others. And of course, not all the teams were the same. Some did this well, others did that well. But they had their strengths. And I want to share these characteristics with you and hope there's something you can take away for your team as well. And like always, those teams also stood on the shoulders of giants. Of course, they didn't pull their stuff out of thin air. They also knew about agile software development, DevOps, and clean coding, and so on. So it's going to be a little bit of mix of well-known practices, observations, and thoughts. So I've split the talk into 3 bigger sections. First is about feedback. Then the next is about mindset. And the last one will be how to set priorities for long-term success. Let's start off with feedbacks. Feedback for us as humans is essential. We rely on it every day. Our body is chock full of sensors and helps us to, to just see what's around us. For example, if we bump into a cactus, we will notice, because of the feedback we'll get. Feedback is essential for learning and for navigating the world. Navigating the world in a physical sense, so feedback from our body. In an emotional sense, so feedback from our thoughts and emotions. And also in a cultural sense, feedback from the people around us. If we move in a culture that is unfamiliar to us and we behave inappropriately, probably we'll get feedback about that as well. There's a tragedy though. Even we have all the capabilities and data we need, still some people ruin their health because they don't listen to their body. Some people ruin their relationships because they don't listen to their spouses. And some people ruin companies because they don't listen to their customers. And sometimes all they would have needed to do was trade their pride with curiosity. Oops. Yeah. So, there's a disease called multiple sclerosis, which impacts your sensory ability. And one of its effects is that it might make you numb. So it impacts your ability to feel. I don't know how extreme it can get, but imagine touching a hot plate and not noticing, so that's pretty bad, right? So without feedback, it's a little bit like this little guy sitting in the burning house and saying this is fine. Pain might be uncomfortable, but it points us to areas that need our attention. And we can either choose to ignore it or use it as a guide. I want to distinguish between two types of feedback: technical feedback that we get from our systems and non-technical feedback. So technical feedback, this is an area that is pretty well covered. We have great observability tools, tools for application performance management, logging, alerting, and so on. And I don't want to go too deep into that. But if you're interested in that area, I can really recommend this free ebook by Google about site reliability engineering, which is a great resource. And we've also borrowed some things from there. And yeah, I'll give one or two examples. So the area I want to dive a little bit deeper into is the non-technical feedback. So yeah, we cannot just get feedback from our technical systems, like I just mentioned, but also from business systems or social systems. So business feedback could be like sales numbers, page impressions, customer retention rate, numbers of support cases, and so on. Also, this area is pretty well covered by the field of business intelligence. So there are a lot of vendors that can sell you tools. You can create reports with them or dashboards, and you'll get a pretty good idea how your business is doing if you monitor the right KPIs, of course. Then there's also social feedback, things like, how is the atmosphere in the room? Are people open and relaxed? Is there a good collaboration in the team? How engaged are people during meetings? And who is talking how often? And these kind of things we usually try to reflect upon in retrospectives, which is great. But if you're observant, you can get it all the time on a day-by-day basis by just paying attention to little social cues or reading the room, seeing how the atmosphere shifts if we mention certain things. Do people start rolling their eyes or something? So these are cues that we can pay attention to. One tool we use from site reliability engineering that I just mentioned is postmortems. So a postmortem is a meeting we run after we had a production incident. So during the production incident, we have one or two developers handling the problem, but there's also a third role we have, and that is the role of a scribe. So the scribe writes down everything that happens. When did it start? Who communicates with whom? How are we progressing in fixing the problem, and so on. And then, once the problem is fixed, the scribe will create a report that could look like this. And then we'll sit down with the whole team and talk about it. So there will be information in this report, like who was on support during that time, when did the incident start, when was it noticed, when was it escalated, when was it fixed, what was the reason, business impact, technical impact, then a list of events, and then there's also a root cause analysis. So you can see that's a lot of information, and that's why we have a separate role of scribe, because otherwise it would be too distracting trying to fix the problem and write everything down at the same time. And so we sit down with the team and talk about it, go over the events, and check, okay, how was the communication? How was the progress? Was there anything that the team was missing? Did we have the right contacts, or did we struggle to get to the right people? Did we have any gaps in our logging or monitoring? And from that then we create follow-ups. That's the last section you see here. And we create tickets and see how we can then improve the situation in the future. So one thing that is essential for this exercise is that it's a blameless atmosphere. So this is not about pointing fingers or to see who messed up, but to make the system better, make the team better, make our processes better. Yeah, and for that you need to be it's good to have this blameless atmosphere, because otherwise people will shut down. So I mentioned multiple sclerosis in the beginning. There is a similar disease in organizations, which I call the green lights disease. So that is people signaling to others that everything is fine, even though it isn't. And as you can imagine, it would be very hard to make good decisions with bad data. But that's exactly what we're doing when we're throwing software over the fence to an ops team somewhere else in the world, or if we outsource our support, if we outsource testing, or if we say everything is fine even though it isn't. So we're depriving ourselves of this direct feedback. And in my opinion, this is one of the biggest values of DevOps. We get this direct feedback from running our own stuff in production. We make the pain visible. We know how well does it work, do we have errors, what are the performance characteristics, and so on. So we get a lot of insights by running that. A couple of years back, I was working for a company, and we did a large migration project, content management system for an editorial team. And so the idea was that they will get a better, more advanced content management system. And we started the implementation, and we did the project and so on. And pretty early on, we felt like kind of resistance from this editorial team. We made sure to involve them early in the process and always gave them like deploy early to get early feedback and so on. And we felt like, okay, there's a little bit of pushback. They are not really excited about this new system. So project went on and so on. And one morning on my way to work, I ran into the CTO of the company. And he was like, hey, you're working on this migration project of the CMS, right? And I was like, yeah. And he was like, okay, how is that progressing? And I was like, yeah, technically it's going well, but you know what? I have the feeling that this editorial team that we do the migration for, they don't really like this new system. They find it cumbersome and hard to use. And he was like, oh, okay, that's interesting. So we chatted on and then goodbye and so on. And a couple of weeks later, this migration project was killed. And so it was very interesting for me to see what can happen if the feedback gets to the right people. Because ultimately, our company invested a lot of money and developer resources into making another team unhappy. And that's surely not what they wanted, right? They wanted them to have a better system, which would make them more efficient. But they didn't like it, and nobody had the guts, or I don't know how it happened. Nobody had the guts to say that, okay, the other team is not very excited about it. And so the project dragged on. But yeah, that's what I mean with feedback routing. Okay, next section, interactions. We as humans want to feel safe. We have the motivation to produce positive outcomes and protect ourselves from negative ones. That's how we learn. Like with running into that cactus, we feel, oh, that's kind of not a great feeling. I probably shouldn't do that again. An error culture tells you a lot about a company. Are people pointing fingers to divert blame? Or do they take responsibility for failures and work together to find a solution. Psychological safety helps fostering a solution-oriented culture. So psychological safety creates a culture where we can admit and discuss mistakes, openly address problems and tough issues, seek help and feedback, trust that our team members are not out to get us, and trust that we are a valued member of the team. And only if we feel safe, we are comfortable to open up and give honest feedback, openly address problems, ask for clarification, or suggest unconventional ideas and think out of the box. So how can we do that? The first thing I would say is assuming good intentions and giving others the benefit of the doubt. People usually want to cooperate and they want to do the right thing. But sometimes it happens that everybody lives in their own, under their own circumstances and has their own incentives and so on, their own constraints. So sometimes these things are not aligned. And that doesn't mean that doesn't mean that somebody wants to do you harm just because they don't go in the same direction as you. They just might come from a different angle. Then also, sometimes it also can be a little bit like when information travels through organizations and you hear strange things. Sometimes it can be a little bit like this game telephone, right? Where you whisper in somebody else's ear, it makes the round, and then on the other end, something completely else and sometimes funny comes out. Next thing is focusing on the solution and not on who's to blame. Solving problems gets us ahead, but blaming just makes people defensive, they shut down, and then it's really hard to work towards a constructive goal. Also, if we want to share something or address something, it's important that we share from our perspective, because we can only speak for ourselves. We don't know what the other person's intentions are. We don't know what their feelings are. So we shouldn't ascribe something to them. For example, if in a post-mortem situation, you could say, how come you were so slow to realize this outage on production? So that's almost like a personal attack, right? And the other will probably get defensive and shut down. Or you could also say, I think we can do better with our reaction time. Does anybody have any ideas how to improve this? So in the second example, you just speak from yourself. This is, I think we can do better as a team. And then you invite the team to be a part of the solution. And lastly, put yourself in the other person's shoes. So just practicing empathy. I mean, it's always good to, or it helps to imagine, okay, how would I react if I would be in the other person's shoes? And that's what I also meant with everybody operates under different constraints and different incentives and so on. And nobody likes to be on the losing end of a deal. So it makes sense to try to negotiate win-win situations and come together where everybody comes out as a winner in the end. So in short, you could say, treat others like you want to be treated. So solution-oriented culture helps us getting the most out of our team. Personal attacks help nobody and only make people get defensive, but addressing problems and getting them out of the way makes us a stronger team. And with that being said, You could think that, okay, solution-oriented culture is good and well, but now we should not address tough issues and everything is just rainbows and unicorns and so on. But by solution-oriented culture, I don't mean like laissez-faire or letting everything slide. I think we can and should expect things from people, like that we treat others with respect, that we stick to agreements, or that we are on time. And also that we are transparent when something is off track. Nobody's perfect and we all make mistakes, but we should own them and learn from them. I think in the end it's a mix of accountability and grace. It's like this spectrum. If we see poor behavior, it's okay to address it, but there's always a place and time, and it's also important how we say that. So, as I mentioned already, I sentence help. Speak from your perspective. Personal attacks usually are not helpful. Be specific. Okay, what was the problem you saw? What was the behavior you didn't like? And what do you want to see instead? Now, next up, of course, my favorite topic as a German, rules and responsibilities. So imagine a place without clear traffic rules. How fast would you dare to go? Last winter, my wife and I went to Mexico, and yeah, it was really nice, great landscape, great people, great food. But one thing we underestimated a little bit was the driving experience. So we had a rental car, and yeah, everything on the road is a little bit more freestyle than we're used to from Europe here. Like here we expect, okay, this is what the signs look like, this is what the traffic lights look like, and so on, and everybody's on the same page. But in Mexico, apparently a local told us it's like this: if you want to get your driver's license, you answer 3 questions, you slap a bunch of pesos on the counter, you get your driver's license, and off you go. Yeah, and with this environment that was a little bit different, sometimes it was really difficult for me to navigate and just, yeah, I was not sure, am I doing the right thing, am I behaving properly? And of course this is critical because if you're doing the wrong thing, you could cause an accident and end up dying in the worst case. Yeah, and so yeah, this is an example of what it looked like. For example, here in this picture, you see a traffic light. So this green sign under the green LED on the bottom side of the sign, and also on the right. So this green arrow. Not sure if you spotted it in the first time, and yeah, this is roughly how it went. So it was a wild guess. Okay, is there a traffic light or not? I think I ran a couple of them. I ran a couple of red traffic lights probably without even noticing. And sometimes you had confusing situations like this. Okay, you have a red light and a green light at the same time. What's going on? So yeah. For me, it was really difficult to be relaxed and go fast because I didn't know what to expect. And that's where I would say, okay, clear rules would have helped me to go faster because I would have known what to expect. And I would have also known what would have been expected from me. So that is also great. So clear rules also foster autonomy. It's easier to do the right thing. I don't have to ask other people all the time, is this right, is that right? No, I just know we're all on the same page and I can do the right thing. Also, yeah, if everybody knows what the rules are and the constraints are, we don't have to discuss things over and over again. For example, in our team, we have this rule that the main branch should be always deployable to production. So if you have a feature that is unfinished and you have that on the main branch, you need to hide it behind a feature flag. Now about the responsibilities. I would say that clear responsibilities reduce complexity, because we can chop up the work, we can assign it to different peoples, and trust that everybody will do their piece, like parallel processing in a system. But not just the work itself, we can also chop up expertise, and then we make it easier because we can focus on a smaller part, and as a team we can cover a larger surface. I think one thing that is important though is that it's always clear, that we are clear with the assignments, who does what. So you might know this situation when you discuss in a team, okay, we should really do this or that, and everybody's, yeah, we should really do this, and then everybody walks away. Yeah, because nobody said, okay, who's going to write the ticket? So, and I think this is the things that I mean. Be intentional with responsibilities and make sure that everybody knows who does it. For example, we also in our team, we have a support rotation. So in the beginning, we didn't have that, and everybody was really looking at the logs and at the monitoring all the time, and that was really distracting. So we thought, okay, let's make it easier for everybody. Just one guy gets distracted and the others can work. And now we have that, and it really makes the life for the team easier, and we just rotate through. In our society, our focus is on talking, because who talks has something to say and looks important. But if you want to understand something, you need to listen first, especially in a field like ours, software development, which is a service-oriented field. We should really focus on listening and understanding the customer requirements, because otherwise we might build the wrong thing. So one thing that helps with that is to practice active listening. So that means if somebody explains something to you, for example, if you have a customer conversation or with some other tech guy or whatnot, then it's helpful to every once in a while pause and summarize what you understood, and then repeat it back to them to just get confirmation. Okay, this is what I stood, and also this is what they meant. And the next thing might sound a little bit obvious, just to ask if something is unclear, but I don't know if you were in this situation before, but to me it happened quite often that I was in a meeting and there were a bunch of people and somebody explained something and like faces started looking a little bit puzzled, but nobody really raised their hand and asked like, I don't know, what are you talking about? And the funny thing is, like most of the time when I did that and just start asking a question, sorry, I'm not familiar with that concept, can you please explain that real quick? I saw not only a light bulb going on over my head, but on several other people's heads as well. So chances are, if you don't understand something, other people might feel the same. And that's where it ties back to this psychological safety. If people feel safe to ask questions, they will do it. But if you have an atmosphere where you're afraid that you might be judged as being stupid or whatnot, then it's a real inhibition to open yourself and in a kind of way make yourself vulnerable. So I just talked about the receiving end of communication. Now let's also talk about the sending end of communication. So poor communication is among the top reasons why software projects fail. So it's important that we are clear and specific and correct with names, because names have meaning. They describe something and that carries implications. For example, if I say architect, probably everybody of you will think, okay, software architect. If I now go out on the street and say architect, probably most people will think of a house architect. So context matters. And good communication helps us build the right thing. Another thing is also abbreviations. We use them a lot, especially in the tech space. In my company, they're especially rampant. But we think we make things faster with them, but often it just adds to confusion and you have to ask. And so if we use them, we should really explain them or have them somewhere on the slide or whatnot. We as software developers, we don't just communicate with words. We also communicate with code. So we communicate across time and across space with our code. Sometimes it's a little bit like with these cave paintings. So the people who painted that also probably wanted to send a message across time. Hey, this is what we did at that time, or this is how we, I guess this is some hunting scene. This is how we hunted some animals. Okay, we can guess what it's about, but it's not quite clear. And sometimes it's the same with our code. And I hope nobody of us writes code that needs an archaeologist to explain it, what it does. Yeah, but still, like, we should make an effort to write not only code that's good for the machine, but it's also good for our fellow humans to understand. And yeah, I mentioned clean code movement earlier. Yeah, also comments help. I know some people say, oh, just write clean code, then you don't need comments anymore. Yeah, sometimes it doesn't work, so make use of them if you need to. Don't be afraid. Yeah. So, another topic in code that can lead to misunderstandings is these kind of values. If we have values that carry unit like duration, cost, timeout, temperature, distance, or also force, it can cause confusion. One very prominent example, some of you might have heard of this, is the Mars Climate Orbiter in 1999. So that was a spacecraft, and something went wrong. The story goes like this. During the design phase, the propulsion engineers at Lockheed Martin in Colorado expressed the force in pounds. However, it was standard practice to convert to metric units for space missions. Engineers at NASA's Jet Propulsion Lab assumed the conversion had been made. This navigation mishap pushed the spacecraft dangerously close to the planet's atmosphere, where it presumably burned and broke into pieces, killing the mission on a day when engineers had expected to celebrate the craft's entry into Mars's orbit. So luckily it only killed the mission and not some people, but still they used pounds for force instead of Newton. I would say the force was not with them on that day. Yeah, so how can we avoid this? One way would be to use value objects, so put the unit right with the value. Sometimes we even have classes there in the JDK already, like with the duration. Or if we don't, like with the money case, we can just write them ourselves. And also, if we cannot use value objects for some reason, then at least we should make an effort to put it in the name what we're talking about. Timeouts is something, and probably you also have come across this, especially when you work with networking code. There are always timeouts involved. And for me, I always wonder, okay, is it now in seconds or is it in milliseconds? And if you get that wrong, it's like you're off by 3 magnitudes. So it makes quite a difference. And these kind of errors can be really easily avoided if we are a little bit clearer with what we mean. Next up, team spirit. Great teams show good team spirit. And what is team spirit? Putting the team's goal first. So not just looking at our own goals and our own incentives, but also following the greater mission of the team. And that could be things like creating documentation that benefits everybody, writing common scripts that make everyone's lives easier, or sharing knowledge in short sessions. Today I learned, or what have you. And so this way you not only get better yourself, but you act as a multiplier and make the whole team stronger. And this is also great if you have a diversified team, because then you have people that come from different angles, from different backgrounds, and that have different strengths. So you can learn much better from each other than if you only have a team with 10x developers, for example. Last section, priorities. Habits can be extremely powerful. Small stuff matters and consistency matters. Because you don't have to think about them, you just do. An example is brushing our teeth. So we usually don't get up in the morning, eat breakfast, and then we start thinking about, okay, should I brush my teeth? Is it a good idea? Is it the right day? Oh, I don't feel like it. Now you just do it. And having good habits as part of our daily routines or work approach can reduce complexity and mental load. So we don't have to think about this stuff. We know, okay, it's just part of the procedure. Can lead to more predictable outcomes because we follow proven procedures and guidelines. And it can reduce team friction if everybody sticks to agreements and we're all on the same page. Good habits that have helped our team succeed are, for example, having automated tests. Having automation in general, good CI/CD pipeline is key. Keeping our defect count low. Keeping our libraries and Java versions up to date. Anybody still using Java 8 here? Yes, you know what I'm talking about. It's always great to ask this question. Somebody always uses still Java 8. So good habits are great, but they also have to be fostered. They don't stick around by themselves. So it's important that we are a good role model, because everybody of us shapes team culture. That we are a good role model. If you see compiler warnings, fix them. If you see an outdated library, do an update. And also remind the people around us that we all want to have our good habits and stick to them and stick to common agreements. One good habit is also to keep it clean. I want to talk about technical debt. That's usually a term when we talk to business people because they understand finance. And that term usually comes up at some point in the project and we say, okay, we need X amounts of week to clean up our mess because it slows us down. But one problem with debt is that it carries interest and it compounds over time. And the longer the time frame, the stronger the compounding. So the sooner you pay it off, the better. Also, with a loan, you go into a bank and they offer you an interest rate. You know what you sign up for, and you can decide to take it or leave it. with tech debt, it's not that simple. You can guess a little bit if it's going to be a little bit of a problem what we're doing here in the long run, or if it's might cause a real problem in the long run, but ultimately you don't really know. And at some point, your tech debt might come at a very unfortunate moment and bite you in the backside. So yeah, we should avoid it. And if we need to do it, yeah, it's best to pay it off right away. Sometimes we have a important deadline on a trade fair, so something really public. Then sometimes we need to cut some corners, but make sure to clean it up afterwards right away. Because one characteristic of tech debt also is that if it accumulates over time, it usually makes us slower and slower. So yeah, but I think that's not hard to argue on a software developer conference. Then the next part is a little bit more difficult. How do we prioritize between features and maintenance work? That's usually where it gets difficult. Because PO always wants more features, 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 and we're like, oh no, we need to work on our stability and so on. So we have two systems in place that help balance features versus quality. The first one is pretty simple. It's called bugs first, and it has two rules. First rule is bugs are always put in the current sprint. So if the support person, for example, finds a bug or errors on production, they create a bug in the current sprint. Second rule is if there are bugs in the current sprint, they always have priority over features. That means if you work on a feature and you're done with your ticket and you want to grab the next ticket and there's a bug in the current sprint, you grab that bug. And you can see how that kind of balances out this features versus maintenance work. Because if our quality deteriorates, we get more and more bugs, then the team will only work on fixing those bugs. Our quality gets better again, and then once the bugs are gone, we can work on features again, plowing ahead full steam, because then we have great quality again. So that's a really simple, but for us a really effective system. The other one the other system that we use is from site reliability engineering, and it's called service level objectives. So the idea is you have a service level indicator, so that's something you measure, like latency or error rate or something. And then you also have an objective for the service level indicator, and service level objective. So, and now you can create things like, or you can create objectives like this. 95% of successful web requests should be faster than 100 milliseconds. Or 99.9% of web requests should be successful. That is an error rate objective. Or 99% of the time Kafka read lag should be below 100. That is an saturation objective. You can look up the term, the 4 golden signals, if you're interested in that a little bit more. And the thing is that you monitor these service level indicators, and if one falls down below the threshold, then the team knows, okay, now it's time to work on stability or on performance or whatever the indicator indicated that is bad. And also you can divide this up, so you don't have just one, necessarily you don't have just one indicator for your whole application, but you could have one for your one for your payment process, for example, that has a different threshold than the one for your catalog, so browsing the catalog or something. So you can chop that up as you need it and make it more aggressive or not, depending on your needs. So, we all want to make smart investments. The problem is, it's difficult to make predictions, especially about the future. So it's helpful to avoid making predictions and think in scenarios. So to ask yourself the question, okay, if this happens, then how can a system cope with that? If that happens, how can a system cope with that? Or if a third thing happens, are we ready for that? And but often there's also some guesswork involved, and often the answer is Yagni, you ain't gonna need it. So don't build something where you're not 100% sure that you will need it. That's a little bit like avoiding premature optimization. Don't try to guess or and come up with generic solutions if you're not sure that you will need them and they also need to be that generic and so on. One of the most important parts here is to avoid painting yourself into a corner. So to get yourself in a position where it's very difficult or very expensive to recover from. One example that we had was we were thinking about switching from Postgres to DynamoDB, but we were not sure really about the performance and the cost characteristics of DynamoDB. I know there's the AWS cost calculator, but have you ever used that? It's like, it has life of its own. In any case, so we thought, okay, we want to have a good feeling when deciding that, because that's going to involve a bit of work. So what we did was, next to our Postgres codes, we also put DynamoDB code, and we hooked it up to a DynamoDB instance, and we did exactly all the reads and writes that we wrote to Postgres. We also wrote to Dynamo. And that made it possible for us to monitor the latency on the one hand of the Dynamo instance and compare it with the Postgres instance. And also it gave us insights into the cost characteristics. And that was really helpful for us to judge whether we want to go down that route or not. So that is one example, but there are some investments that always pay off, that are always smart to make. For example, having automated tests. Did I mention that already? Or having CI/CD pipeline, having coding guidelines, having good monitoring, or keeping your tech debt low. So in short, make the most of what you know, but avoid assuming what you don't know. One thing that's also important is to leave some room for improvement and innovation. Yeah, it's important that we don't get bogged down in feature work and make as fast as we can, but never have the space to breathe, sharpen our axe, or put some wheels on that work better or so. So it's always good to have some time and reserve some time to check out new things and see, okay, are there things that can improve the life of the team and make our work easier? Don't be too busy to improve. So to sum it up, feedback, better data leads to better decisions. Then pain is uncomfortable, but we can use it as a guide. What parts need attention? Also, it's helpful to create an environment of safety and trust that makes collaboration easier, that makes it easier for people to open up and speak honestly. We can avoid misunderstandings by listening carefully and communicating clearly. And therefore, avoid building the wrong thing. Clear rules and responsibilities help us go faster, and keeping our code clean and making smart investments will ensure the success of our project. Thank you very much. With this, I think we're at the end. I'm not sure if there are any questions in Slido. I'm just gonna check. Room 11. Here comes the window. And it's pretty empty. I have to switch. Ah, ha. That's a hot tip. Still empty. How great is that? No questions. Well, then I wish you a great conference, and yeah, see you around. Thank you very much.